In this video, we will learn how to find the particular integral of second and higher order linear differential equations with constant coefficients. A linear differential equation with constant coefficient is of the form this. Here, our dependent variable is y and independent variable is x. And this a1, a2, a so on up to an minus 1, an all are constants, and this capital X can be a constant or it can be a function of independent variable x only. So here if this x is 0, in that case we call this equation homogeneous linear differential equation. And in that case, our complete solution will be equals to complementary solution only, which we have already discussed in the previous video. I'll put the link in the description box. And second case is when this x is not equals to 0. If x is not equals to 0, but if this is a function of x, means independent variable x, then the equation is called as non-homogeneous linear equation. And in this case, along with the complementary solution, we have to find the particular integral also. So our complete solution in this case will be equals to complementary solution plus particular integral. So we will see how to find the particular integral in this video. So in this lecture, we will see how to solve the non-homogeneous linear differential equation with constant coefficient. So here I'll take one example in order to explain this concept. So let's take this example. So what is the first step? First step is to write the symbolic form. What is the symbolic form? So symbolic form is d square y minus 3 dy plus 2y equals to e power 5x. So this is d square minus 3d plus 2y equals to e power 5x. So this is my capital X. This is f of d and this is dependent variable y. So here capital X is a function of x. This is not 0. That's why this is non-homogeneous linear differential equation. Okay. Now what is second step? Second step is to write the auxiliary equation. So what is auxiliary equation? Auxiliary equation used to be f of d equals to 0. What is f of d here? F of d is d square minus 3d plus 2 equals to 0. Now next step is to find the roots of this equation. To find the roots of auxiliary equation. So what are the roots? So this is d minus 1 and d minus 2. So roots are d is equals to 1 and 2. Okay. Now what is the fourth step? Fourth step is to write the complementary function. I know how to write the complementary solution or complementary function. We have done this in the previous video. You can check that from last video. So here we are having distinct roots, real and distinct roots. So how to write the complementary solution? C1 means first constant, e power first root into x, okay, plus C2 e power second root into independent variable x. So this is my complementary solution. Okay, so I'm going to write this complementary solution here. Fine. So we are done with the complementary solution now, but because this is non-homogeneous, so in this case, we have to find the particular integral as well. Okay, so what will be the next step? Next step is to find the particular integral. Okay, that I'll tell you later on in the next slide. Okay, so next is to write the complete solution. After calculating the particular integral, what we will do? We will write complete solution as y is equals to, means dependent variable equals to complementary function plus particular integral. Okay, now how to find the particular integral for different cases, that we'll discuss on the next slide. Before doing anything, we must know what is inverse operator. So inverse operator is 1 over f of d. We have already seen what is f of d. So here d is actually derivative with respect to the independent variable. Here I am assuming my independent variable is x. So that's why capital D will be d over dx. Okay. And what is particular integral? When this operator is operated over the function capital X, you know what is x. Okay. So capital X is a function of independent variable small x. So when this operator operated over this, that will give you particular integral. Okay, and here positioning of the functions are also very important. So this operator operated on the things which are on the right hand side. Okay, for example, if I write x square 1 over f of d capital X, So this operator will operate on capital X. It will not affect x square. This is similar to this, like for example, if I have x square integration of 2x dx. So this integration will be applied over 2x. It will not affect this x square. Same thing is applied here also, in this case also. So positioning is very important, and this is just like the integral integration or derivative. This operator is just like that. Okay, so one thing, if let's say f of d is d, then you will get 1 over d into this capital X, where capital X is what? This is some function of x. 1 over d f of x means integration of f of x with respect to x. Okay, similarly, if you have 1 over d square into some function, then that means double integration of that function with respect to x. Okay, and if you have d into some function, that means derivative of that function with respect to independent variable x. And if you have d square fx, that means second order derivative of that function with respect to x. And similarly, we can proceed with the higher orders also. Okay. Now let's see how to find the particular integral. So first thing is rule number 1. So rule number 1 is, if your capital X is e power ax, if your capital X is of this type, then how to find the particular integral? So 1 over f of d e power ax will be your particular integral, and in this what you can do, you can just place d is equals to a. Okay, provided your f of a should not be 0. Okay, so let's see this along with one example. So this is our example. First thing is to write this into which form? Symbolic form. So d square minus 5 d plus 6 y equals to e power 4x, right? Now next is to write auxiliary equation, that is d square minus 5d plus 6 equal to 0. Next step is to find the roots. So what will be the roots? D minus 3 and d minus 2. So roots will be 2 and 3. So because roots are real and distinct, that means here what will be the complementary solution? So complementary solution is first constant e power first root into independent variable, second constant e power second root into independent variable, right? Now next is to find the particular integral. So according to the rule, what will be the particular integral? So particular integral will be equals to 1 over f of d into whatever the function we have on this side, that is e power 4x. What is your f of d? This is your f of d. Okay. So 1 over d square minus 5d plus 6 e power 4x. Now according to the rule, what should I do? I have to put d is equals to a. Here in this case, what is my a? A is 4. So put d is equals to 4 here. So what will we get? 4 square minus 5 into 4 plus 6 e power 4x as such. Now what we will get? 16 minus 20 plus 6. So 16 plus 6, 22 minus 22. So 1 by 2 e power 4x. Now see, this is free from d. Okay. Now we are not having any d operator here. So this is my particular integral. Okay. This is my particular integral. So what will be your final solution, means complete solution. So complete solution is, I am writing here, complete solution is your dependent variable. What is our dependent variable? Y. Y is equals to complementary solution plus particular integral. So that will be equals to, what is this? What is our complementary solution? That is c1 e power 2x plus c2 e power 3x. And what is your particular integral? That is 1 by 2 e power 4x. So this is my complete solution. Alright, I hope this is clear. There was one condition in the last rule, that was f of a must be non-zero, right? But what if f of a is 0? Then what we will do, that we will see in this next question. The next question is this. Here left hand side is same as the last question, and this right hand side has been changed. Now we are having e power 2x. So what is f of d? Symbolic form is d square y minus 5 dy minus 6y equals to e power 2x, and this will be d square minus 5d minus 6y e power 2x what is this? This is our f of d, okay, and y equals to e power 2x. Now, because this is same as the previous one, roots will be 2 and 3, okay, so complementary solution will be c1 e power 2x plus c2 e power 3x, okay. These are the roots of auxiliary equation which we have already solved for the previous question, okay. Now what will be the particular integral? So particular integral will be equals to 1 by f of d into e power 2x. So what is f of d? F of d is 1 over d square minus 5d minus 6 e power 2x. Now what I need to do, using the last rule, because we have e power ax type of function here, we must put d is equals to 2, right? Because what is the coefficient of x here? That is 2. So we have to put d is equals to 2. So if I put 2 here, what we will get? 2 square minus 5 into 2 plus 6. So 10 minus 10. So we are getting 1 over 0, right? So this is called as case of failure, okay? So this is our case of failure. So in case if you are getting f of a is equals to 0, then what we will do, we will multiply one independent variable x from the left hand side. This is very important. Positioning of the elements are very important. From the left hand side we will multiply x, okay, and we will differentiate f of d with respect to d. Alright, and on the right hand side you will have e power ax, and then again we'll proceed according to the previous rule. Let's see how. So here, because we are getting 0 here, so what we will do now, this is my f of d, so we will just differentiate this and we will multiply 1x from right left hand side, okay. So we will get x 1 over, what is the derivative of this? That is 2d minus 5. So we are differentiating with respect to d, okay, e power 2x, right. Now again we will put d is equals to 2, okay. So what we are getting? X 1 over 2 into 2 minus 5 e power 2x. So this will be equals to 4 minus 5 minus 1. So this will be x 1 minus 1 e power 2x. So what is my particular integral? See, now we are not having any d operator. Okay, so this is our final result for particular integral. That will be minus x e power 2x, right? Now let's assume in case if you are again getting 0 here, that again what you need to do, you have to multiply 1x from this side and you need to differentiate this function again, okay. Are you getting my point? That if you are getting a 0 again in the denominator after putting d is equals to 2, then you have to multiply 1x again from this side and you have to differentiate this function again with respect to d. Okay, and one more thing, why we place this x on this side? Because this x will not be affected by this operator. Okay, that's why we place this x on the left hand side. Now let's discuss the next case. So now we will discuss rule number 2. So if capital X is sin AX, cos AX plus B, or sin AX plus B, then we will operate this rule. And here what we will need to do, in order to get the particular integral, we have to put d square is equals to minus of a square. What is a here? A is the coefficient of x. And here please observe that d square is not minus a whole square. This is negative of a square, right? So this will be operated only over d square. If you are having d in your f of d, we will not operate anything. We cannot put d is equals to minus a or d is equals to iota or something. Okay, so we can operate only over the d square, and f of minus a square should not be 0. Fine, this is one condition. Now let's understand this along with one example. Now see, this is a example. So first thing is to write the symbolic form. So that will be d cube y plus d square y minus dy minus y equal to sine 2x. Okay, d cube plus d square minus d minus 1y equal to sine 2x. Alright, and now this is my f of d, y equal to sine 2x. So auxiliary equation is f of d equal to 0. This is our auxiliary equation. So what is f of d? That means d cube plus d square minus d minus 1 is 0. So if I calculate the roots are 1, minus 1 and minus 1. So this is real. Okay, all three roots are real, but these two are repeating. So how we'll write complementary solution? That will be c1 first constant e power first root 1 into x. Now because minus 1 is repeating 2 times, so we will assign two constants corresponding to minus 1 along with the increasing power of independent variable x. So c2 plus c3x e power minus 1 into x. This is our complementary solution which we have covered in the last video. So now we will focus on the particular integral. So how to find the particular integral? So particular integral is equals to 1 over f of d and whatever the function you have here. Now this time we are having sine 2x. So here you will have sine 2x. Now what is f of d? F of d is 1 over d cube plus d square minus d minus 1. This one. Sine 2x. Now according to the rule we can operate only over the d square. So can I write this d cube as d square into d? So here we'll split this and we'll see what we will get. So here d cube I am writing as d square into d plus d square minus d minus 1 sine 2x. Now what is a here? In my case a is 2. Okay, here a is what? That is the coefficient of x. So here we need to put d square is equals to a square means 2 square negative. So means minus 4. So if I put this thing here, what we will get? So see 1 over d square. Here I am putting minus 4 d plus this d square will again minus 4 minus d minus 1 and sine 2x. Okay. Now let's see what is next step. So just add this minus 4d with minus d and minus 4 with minus 1. So what we will get? So we will get 1 over minus 5d minus 5 sine 2x. So we can take 1 by minus 1 by 5 common. So here you will get d plus 1 sine 2x. Now because our rule is applicable over d square, we can put d square is equals to minus a square. So what to do with this d? So in order to have d square here, we will multiply and divide with d minus 1. Okay, d minus 1, d minus 1. So that we can have that formula a square minus b square and we can get the squaring of d in denominator. Okay. So here what we will get? So we know the formula a plus b, a minus b used to be a square minus b square. So by using that formula what we will get? So this is equals to minus 1 by 5 d square minus 1 d minus 1 sine 2x. Okay. And here now we got d square in the denominator. So what we will get? This is minus 1 by 5. So we will put d square is equals to minus 4 again. So here what we will get? Minus 4 minus 1. Okay. And here we have d minus 1 sine 2x. So this will be minus 5 into this negative into 5. So 1 by 25 d minus 1 sine 2x. This is not our final solution because d is still here. Okay, this d is still here. And what is d? D is the derivative of this with respect to x. Okay, d is the operator which is actually derivative with respect to the independent variable x. And in my case, independent variable is x, right? So now we'll take this sine 2x here inside. So what you'll get? 1 by 25 d sine 2x and minus 1 into sine 2x minus sine 2x. Now d sine 2x means derivative of sine 2x with respect to x. So what is the derivative of sine 2x with respect to x? That is 1 by 25 2 cos 2x minus sine 2x. Now you can see we are not having any of d operator. Okay, so this is a final result for particular integral. This is a particular integral. So complete solution will be complementary solution plus particular integral. We have already calculated both the things. So complementary solution though I have erased, but that was c1 e power x plus c2 plus c3 x e power minus x. And what is our particular integral? That is 1 by 25 2 cos 2x minus sine 2x, because we are not having space here, so that's why I have written over this. So this is my complete solution. All right, now let's see the next part. Now next question is d square y over dx square plus y is equals to sine x. So here what is the symbolic form? So d square y plus y equal to sine x. Alright, so this d square plus 1 y equal to sine x. So what is the auxiliary equation? Auxiliary equation is d square plus 1 equals to 0. So from here d will be plus minus iota. And we know how to write the complementary solution for these type of roots. So we are getting complex roots. So complementary solution will be, what is the real part? Real part is 0. So e power 0x into first constant cos imaginary part. What is the imaginary part? Imaginary part is 1. So 1 into x plus c2 sine imaginary part, that is 1 into x. So this is a complementary solution. Okay, so e power 0 is 1. So this will be, complementary solution will be c1 cos x plus c2 sin x. Alright. So now in this video our focus is to learn how to find a particular integral. So now let's see how to find particular integral for this particular question. So particular integral will be 1 by f of d into whatever the function you have here. So here we have sin x. Alright. So what is f of d? That is d square plus 1. And here we have sin x. So according to the previous rule, we have to put d square is equals to minus of a square. And what is a? A is the coefficient of x along in this sine function. So what is here? Here along with x we are having 1. So a is 1 in this case, right? So d square will be minus of 1 square. So minus 1. Put d square is equals to minus 1. So what we will get? Minus 1 plus 1 sin x. Here we are getting 0 in the denominator, right? We are getting 0 in the denominator. So that means this is a case of failure. Okay. So in case of failure, what we need to do? Same thing which we have done for the exponential. So here we will multiply one independent variable x from the left hand side, and we will operate derivative. We'll differentiate this function with respect to d, and again we'll proceed according to the sin ax. Let's see how. So here, because this is my f of d, okay, and because we are getting 0 after placing minus 1 equals to d square, okay, so what we will do, we will multiply 1x from the left hand side, okay, and we will differentiate this. So what you will get? 2d. What is the derivative of d square with respect to d? That is 2d, and 1 will be 0 because 1 is constant, so derivative of 1 will be 0. Sine x, okay, so we get x over 2 1 by d sine x. So I told you 1 by d into something means actually integration. So 1 by d f of x is actually equals to what? Integration of that function with respect to x, right? So what does it mean? This means integration of sine x with respect to x, okay? This is equals to x by 2 integration of sine x dx. So that will be, what is the integration of sine x? That is minus of cos x, right? So answer will be minus cos x into x by 2. Now because here we are not having any d operator, okay, so this is our final answer for particular integral. So just keep this thing in your mind that we have to solve the particular integral until we are having d involved in our solution. Okay, so you'll get the final answer only after eliminating the d, after doing everything with the d. Okay, once d derivative, d operator is vanished, that means you got the final answer for particular integral. Now what will be the complete solution? So the complete solution will be equals to complementary solution plus particular integral. So what was the complementary solution? Complementary solution was, and yes, this is equals to y, dependent variable. Y is equals to complementary solution plus particular integrals. So what is complementary solution? That was c1 cos x plus c2 sin x. And what is particular integral? This is our particular integral. So minus x by 2 cos x. This is our complete answer. Okay. So in this video I have discussed only first two rules, and remaining rules we will discuss in the next lecture. Thank you very much.